Hello everyone, today we'll see IUPAC nomenclature. So using this IUPAC system, so we'll see how to write a name for an organic compound. So in this nomenclature, so there'll be 4 parts, and the first one is root word. Okay, so every organic compound will have this root word, plus it will have a primary suffix. It will have a primary suffix. So every compound, every organic compound will have these two. It is root word and primary suffix. And the compound may have secondary suffix. Secondary suffix. And some compounds may have prefix also. Right? So, but every compound will have this root word and primary suffix. So these two will be common for every compound. And what is this root word and this primary suffix? How do we write this root word and this primary suffix? So this root word indicates the number of carbon atoms in the longest chain of that compound. So I will explain what is this longest chain of a compound. So the number of carbon atoms in the given compound will be represented with this root word. In the sense, for example, if there are 1 carbon atom, so here I am writing number of carbon atoms. So if 1 carbon atom is there, then the root word will be meth. So this will be the root word for a compound which is having 1 carbon atom. If there are 2 carbon atoms in the longest chain of that organic compound, then the root word will be it. And if there are 3 carbon atoms, it will be prop, and for 4 carbon atoms it will be a but, and for 5 carbon atoms it is pent, and for 6 carbon atoms it will be hex. And we are not going beyond this 6 carbon atoms for this class 10 level. Okay, and coming to this primary suffix. This primary suffix indicates the nature of carbon-carbon bond, because the bonding between carbon atoms may be a single bond, or it may be a double bond, or it may be a triple bond. Okay, so this is nature of carbon-carbon bond. It can be a single bond, it can be a double bond, or it can be a triple bond. In case if all the carbon atoms have single bonds, only single bonds in the given compound between the carbons, all are single bonds, then the primary suffix will be "ane." So this primary suffix always follows this root word, and if at least 1 double bond is there between carbon and carbon, then the primary suffix will be "ine," and if at least 1 triple bond is there, then the primary suffix will be "ine." Okay, let's see an example. If I have this compound CH3, CH2, CH3, right? So here I have only one chain. I have only one chain here. You have to start with the root word. So we always start with the root word. So for the root word, you have to see how many carbon atoms are there. So here how many carbon atoms are there? 1, 2, 3. 3 carbons are there. So let's write the root word for 3 carbon atoms. So how many carbon atoms? 3 carbon atoms are there. So for 3 carbon atoms, what is the root word given? Prop. So write prop here. So the root word of this compound is prop, and root word followed by the primary suffix. Now, so how do we write the primary suffix? Nature of the bond. You have to see the nature of the bond. Between the carbons, Here is a single bond, here also a single bond. So all are single bonds between the carbon atoms. Since it is a single bond, for single bond you will write ane. So that's all. So this is the name of this compound, propane. So prop for 3 carbon atoms and ane represents the nature of the bond between the carbon atoms. Right? So this is a hydrocarbon. So the name of this hydrocarbon is propane. So why do we call it as a hydrocarbon? Because it is made up of carbon and hydrogen only. Okay? So it is made up of carbon and hydrogen only. So it is called a hydrocarbon and its name is propane. Okay? Right. Then what is this secondary suffix? What is this? Secondary suffix. So this secondary suffix is given when there is a functional group. If functional group is there, then we will write that functional group. Okay. So what is this functional group? We have these functional groups. The functional groups, what we have? C double bond O, OH. So this functional group can be written as COH. Okay, the same can be written as this. And this is called carboxylic acid group. This is called carboxylic acid group. And if this functional group is present, in the given compound, then the secondary suffix to be written is oic acid. So you will write this oic acid after this primary suffix if this COOH is there, and the other one is C double bond OH, and this can be written as CHO. The same thing can be written as CHO. So this is a bond. Okay. So CHO. This is called aldehyde group. This is called aldehyde group, and when this functional group is there, the secondary suffix will be Al, AL, and if you have this one, C double bond OC. Okay, so carbon will be having bond both the sides and double bond O. So then it is called ketone. The functional group is called ketone functional group, and the secondary suffix will be on. Okay, the secondary suffix will be on for this ketone. And if this functional group is there, OH, the OH will be bonded with carbon atom. So this OH is nothing but alcoholic group. It is an alcoholic group, or we call it as alcohol. Okay, so when this alcoholic group is there, you will write secondary suffix as OL, all. Let's see an example. CH3, CH2, CH2, CHO. Now, even here we have only one chain. Okay, it's a straight chain. So that will be the longest chain. And we start with the root word always. So what is the root word here? So root word means how many carbon atoms are there in the chain. Now look at how many carbons are there. 1, 2, 3, 4. 4 carbons are there. So for 4 carbons, what is the root word given? For 4 carbons, you will give but as a root word. And nature of the bond between the carbons. Between the carbons, nature of the bond. Carbon, carbon, single bond. Carbon, carbon, single bond. Carbon, carbon, single bond. So all are single bonds. So for all single bonds, you will write N. Okay. Now you have this functional group CHO. So when you have this CHO, what is the CHO? This is aldehyde group. So when you have this CHO aldehyde group, what is the secondary suffix? That is AL. Okay. So before you write this secondary suffix, you have to remove this E from this N and write or add that AL. So now it will be butanal. Okay, so it is butanal. Let's see another example. CH3, CH2, CH2, OH. So now, even now we have a single straight chain. Okay, so you will take this as the main chain because you have carbons up to here. Okay, you should not include this OH. You have to take the carbon chain only. So in this carbon chain, so how many carbons are there? 1, 2, 3. 3 carbons are there. So now this will be for 3 carbons. You will write prop, and all are single bonds. Carbon carbon single bond, carbon carbon single bond. So you will write N. And you have this alcoholic group OH. So when you have this alcoholic group, so what will you write? You will write all. Okay, secondary suffix will be all. And whenever you write the secondary suffix, you have to remove this E and then you will add this all. Okay, and but this OH can be attached to this and this OH can be attached to this carbon or this carbon. Okay, it is possible. So you have to give the position of OH in this case. You have to mention the position. So on which carbon this OH is present. Okay, and you have to give numbering to the carbons in the main chain. So how do we give numbering now? So you can give numbering like this 1, 2, 3 like this, or you can give 1, 2, 3 like this. But which one is the correct method? So remember that. So when you give numbering, so you have to make sure that the functional group gets the least number. That means you have to give priority to the functional group. You have to give priority to the functional group. So functional group is on the right side. So you have to start numbering from right to left. So 1, 2, 3. You have to give numbering like this. Okay, so that will be the correct method. Now look at on which carbon the OH is present. The OH is present in the first carbon. So that is the position of OH. So that's why this will be propane 1 ol. Okay, so this 1 represents the position of the alcoholic group. So here the alcohol is in the first carbon. So it is 1 ol. And the name becomes propane 1 ol. And we may bring this one to the front and it becomes 1 propane ol. Okay, so when you write the number and the word, that should be separated with hyphen. Okay, between the word and number there should be a hyphen, remember that. So this is how we write the secondary suffix if there is a functional group. If there is no functional group, we just ignore the secondary suffix. Okay, the next one is prefix. When do we write the prefix? You will write prefix only when there is a substituent or a branch. Okay, only when there is a substituent, you will write this prefix. I will tell you what is a substituent. Okay, see for example, you have this compound CH3, CH2, CH2, CH3. Okay, so now can you name this compound? So we have only single chain and see how many carbons are there for this root word. 1, 2, 3, 4. 4 carbons. You will write but and all are single bonds. Butane. No functional group, so no secondary suffix. Now this is a butane. So if any one of these hydrogens, say here I have CH2, 2 hydrogens are there. If one hydrogen is replaced by some other group or some other atom like Cl, okay, so then we call it as a substituent. We call it as a substituent. And so what atoms or what elements or what groups can be a substituent? Okay, so generally the substituent what we have are, so it can be CH3. Okay, CH3 is methyl substituent. Okay, or methyl group. So the prefix what you write will be methyl only. And it can be Cl like this. Okay, if Cl comes, you will write chloro. If Br comes, you will write bromo. If fluorine comes, you will write fluoro. And if iodine comes, you will write iodo. So like this you are going to write the prefix if there is a substituent. If there is a substituent. If there is no substituent, you are not going to write the prefix. Okay. So let's write the name for this. Okay. So here you got the substituent, right? So now first you have to take the main chain or the longest chain. Okay. So you can see a branch over here, but you have to take the chain like this. Carbon chain only. So all contain carbon atoms. Okay. Now first name that main chain starting with the root word. So always we start with the root word. Remember that. So root word. Root word, it indicates the number of carbon atoms. See how many carbons are there. 1, 2, 3, 4. 4 carbons are there. So this will be but. And in the main chain between the carbons all are single bonds. So this will be butane. And no functional group over there, so no secondary suffix, but you have a substituent over there, right? So you will write prefix. Okay. So now what is the prefix for this chlorine? For this chlorine you will write chloro. You write chloro, and you have to show the position of that chlorine atom. Okay. So how do we show the position of the chlorine atom? By giving numbers to the carbon atoms. 1, 2, 3, 4. And again you have to make sure that when you give number to the carbon atoms, the chlorine must get the least number. Okay. So from left to right will give. So what is the position of chlorine? It is 2-chloro-butane. Okay. Let's see another example. If you have a compound like this, CH3, CH2, CH2, CH, CH3, and here CH3. Okay, so again you have a branch over here, so you have to select the longest chain. Okay, carbon chain, longest carbon chain. So this will be the longest carbon chain. Okay. Now, so first we start with the root word. So let's see how many carbons are there in the main chain. So 1, 2, 3, 4, 5. 5 carbons are there. So for 5 carbons, what is the root word? Root word will be pent, and primary suffix carbon-carbon bonds. Carbon-carbon single bond, carbon-carbon single bond. So all are single bonds, right? So this will be pentane. And we don't have a functional group, so no secondary suffix, but you have a substituent. So you have to write the prefix, right? So what is the prefix here? CH3. What is CH3? Methyl. So we'll write methyl here, right? And but what is the position of this methyl? Then you have to give numbering to the carbon atoms. So now again you may give numbering 1, 2, 3, 4, 5 this way, or 1, 2, 3, 4, 5 this way. But which is the correct method? You have to give numbering in such a way that the functional group or the substituent will get the least number. So the substituent is on the right side. So you have to give numbering from the right side only, from right to left. Okay, so starting from here, first carbon, second carbon, like this. So this is the correct method. Okay, so remember that. So whenever you give numbering, you have to remember. So you have to give numbering in such a way that the functional group or the substituent will get the least number. So you have to give priority to that functional group or that substituent. Okay. So now position of methyl group is second carbon. So 2-methyl pentane. Okay, let's see another example. Sometimes we will have more than one substituent of the same kind, like CH3, CH2, CH, CH, CH3. If you have this kind of example, okay, again we start with the root word with the main chain. So first of all you have to take the longest chain of the compound. Okay, so first main chain, 1, 2, 3, 4. 4 carbons are there. So for 4 carbons, what do we write? But. And all are single bonds. Carbon-carbon single bond, carbon-carbon single bond, carbon-carbon single bond. So you will write ane. Now you have 2 substituent of the same kind, that is chlorine. So you will write chloro. You will write chloro. But you have twice this substituent, twice here. So for two chlorine atoms, you will write dichloro. So di means the same substituent has repeated twice. Okay, so dichlorobutane. But what is the position? So if you give a number like this, 1, 2, 3, 4. So one chlorine is on the second carbon and the other chlorine is on the third carbon. So second and third carbon, you will show here 2, 3 dichlorobutane. And when you write the number, between the numbers you will use comma, and between the number and the word you will use hyphen. And sometimes the same substituent may repeat 3 times like this: CH3, CH, CH, CH2, CH3, chlorine, chlorine, and here one chlorine. So now in this case, again you start with the root word with the main chain. 1, 2, 3, 4, 5. 5 carbons. So what do we write? We write pent. You will write pent. All are single bonds in the main chain, so it will be pentane. That ane represents all are single bonds in the main chain or in the longest chain. And what is the substituent here? Chlorine, chlorine, chlorine. So 3 times chlorine. So you will write chloro, but 3 times it will be trichloro. Trichloro. And coming to the positions. So 1, 2, 3, 4, 5. So now second carbon has 2 chlorine substituents. So you will write 2, 2. That means 2 chlorines are present on the second carbon and 1 chlorine is present on the third carbon. So total 1, 2, 3 trichloropentane. 3 chlorine atoms are there. So, and positions 2, 3 trichloropentane. So this is how we write the name of the compound.